Dear students, I welcome you all in the second lecture of this lecture series on advanced welding. Today we'll discuss the definition, classification and applications of welding. So how do you define welding? Welding is a fabrication process in which two or more parts are joined together by means of heat, pressure or both. This is very general and simple definition of welding. Variety of books you will find a very complicated and very complex type of definition. So to understand this definition, we'll focus on these three technical keywords which are bold and underlined in the definition. As you can see, the first keyword is fabrication process. So we'll understand these three technical keywords one by one. So a fabrication is basically a creation. So to create a part or a component, we use variety of fabrication processes such as soldering, brazing, mechanical fastening, adhesive bonding, and obviously the welding. We'll compare these fabrication processes one by one and compare it with welding. So first of all, soldering. As you can see in this figure, this is showing the soldering process. Soldering is done with the help of a wire, which is called solder. This wire is made up of generally low melting point materials like silver, zinc, tin, etc. And this wire is heated and melted with the help of this soldering gun. This is soldering gun. With the help of the soldering gun, this wire is heated, melted, and deposited on the desired location where we want a bond. So this solder, or you can say solder joint or bond, is not mechanically that strong because there is no heating on the substrate or base metal side. Only solder is heated and deposited. So the mechanically this bond is very weak as compared to weld joint, but this is electronically very strong. So this type of joining or soldering can take place in the electronic industries. Okay. So the basic difference between soldering and welding is the melting. Here the in welding, both the base metals are heated, filler wire is heated and melted and fused together, whereas in soldering, only this wire or solder is heated and melted. There is no such melting at the substrate. And second fabrication process is brazing. Brazing is similar to soldering. You can see a brazing process here. This wire, which is generally made up of copper, which is comparatively of higher melting point as compared to solder, generally higher than 400 degrees centigrade. This is heated and melted with the help of this brazing gun. So you can say the solder joint is comparatively stronger than solder. This braze joint is comparatively stronger than solder joint, but it's still comparatively weaker than weld joint. So this soldering and brazing has been compared with the welding. Now it is mechanical fastening. Mechanical fastening, as you can see, rivet joints and nut bolts in like very day-to-day applications. This is an application of rivet joint. These are called these cylindrical pieces which have this head type structure. They are called rivets. They are placed where we want to tie two parts, two plates or two cylindrical parts, any type of shape or geometry. So these are all rivets. This 1, 2, 3. They all are rivets. To get this rivet joint, what we do, we just drill a hole. Suppose in this plate, we drilled a hole here. We inserted the cylindrical part there. One side it is head, already a head, and second side is without head. So at this without head side, we just hammer or put some, use some mechanical press for compress this type of, this end of the rivet so that a head shape type or dome shape type shape is formed. So this is how we get a rivet joint. You can see a number of rivets are there in the this plate. You can see these riveted joints in the sheet metal work, like in desert cooler body, or in so many day-to-day applications. This second type of mechanical fastener is bolted joint. You can see this nut bolt type joint everywhere in the day-to-day applications. So basically, this is called nut, and this long cylindrical part is called bolt. Wherever these are two parts, this is one and this is two. If we want to tie or join together these two parts, we just drill a hole of a proper shape or size, or we can say we choose the this diameter, outer diameter of bolt as per the hole size drill, which is drilled in the plate. So we just inserted this long cylindrical part, that is bolt, and we just tie or fix this bolt with the help of this nut, with the help of these threads. So this bolted joint, or you can see nut and bolts, are generally temporary type of joint, because it is very easy to detach. If we if we want to disassemble these two plates, we just lose or remove this nut part and remove this bolt. So that is how it is very, very easily disassembled. Whereas to disassemble this rivet joint, solder joint, brace joint, or weld joint, it is very difficult. Like the if we want to detach or disassemble this rivet, solder, or brace weld joint, we need to destroy the joint. Like we need to destroy rivet to disassemble riveted parts, or we need to destroy the solder or brace to disassemble. So they all are permanent joint, whereas this bolted joint is a temporary joint. Fourth type of fabrication process is adhesive bonding. Adhesive bonding is happened or takes place with the help of some chemical components like epoxy and glue. Wherever we want to wherever we want to join two parts, we just apply epoxy and glue on the surfaces to be joined, and they are like they allowed to dry, so that a chemically strong bond can be obtained. So adhesive bonds are chemically strong bonds. The mechanical strength, etc., is like comparatively lesser than weld joint. So this is all about the fabrication processes. So we can see if we compare in a large picture, a weld joint is comparatively mechanically stronger than all these four types of joint. A welded joint is a type of permanent joint. They are very strong, and that is why it is used in very critical operations. So second keyword is two or more parts. So why I have given emphasis on this technical keyword, two or more part. Two or more is fine, but here I use term parts. In some books you have found the term metal in the definition of welding. But I want to clarify you, and it is a general misconception in the students that welding is used to join only metals, but it is wrong. Welding can be used to join metals, composites, thermoplastic, and woods. So welding is a joining process which can be used for variety of materials, not only just of metals. So please keep this point in mind. Third keyword is heat, pressure, or both. Welding can be taken place with the help of heat alone, pressure alone, or application of heat or pressure both. So I have categorized all the welding processes based on this the or mechanism of the joining. Like there are some processes in which only heat is used to join the part. They are arc welding, gas welding, laser beam welding, electron beam welding, electroslag welding, and thermite welding. Whereas in some processes, only pressure is used to get a joint, like diffusion bonding, explosion welding, friction welding, and friction stir welding. In some cases, both heat and pressure are used for joining. These processes are categorized in resistance welding part, like spot resistance welding and seam resistance welding. We'll study all these processes, the mechanism, the components, and the joining part, the characteristic joint, and the possibility of occurrence of defect, etc., or in all these processes in the subsequent lectures of this lecture series later on. Okay, now moving forward towards classification of welding. There are variety of welding processes. They are categorized basically in 5 categories. You can see here, there are 5 categories. The first category is gas welding. Gas in welding, gas is used to produce flame. So flame is used as a heat source to heat and melt the metals generally. So based on the gas composition, they are further categorized as oxyacetylene welding, air acetylene welding, and oxyhydrogen welding. Second category of welding is resistance welding, in which, as the name suggests, In this, electrical resistance is used to produce the heat, and like after heating, with the help of that heat, the melting of base metal takes place, and further on the joining takes place. So this resistance welding comprises of butt resistance welding, spot resistance, seam resistance, and projection resistance welding. Third category of welding process is arc welding. In arc welding, there are further other categories based on the variety of arc, like carbon arc, metal arc, plasma arc, gas metal arc welding, and gas tungsten arc welding. Fourth category is related to some innovative and newer welding processes like electron beam welding, in which a very concentrated electron beam is used to produce the heat, or the source of heat is electron beam, you can say in general. The second newer welding process is laser beam welding. In laser beam welding, a laser beam a laser beam acts as a source of heat to melt the base metals. Fifth and last category of welding process is solid state welding. Solid state welding, in which the highest temperature of base metal reaches below the melting point of material. So you can say the joining takes place below without the melting of the substrates or base metals. So they are further categorized as friction welding, ultrasonic welding, diffusion welding, and explosive welding. Broadly, if you can see, or in all these four categories like gas welding, resistance welding, arc welding, or in newer or innovative welding processes, all processes have the temperature higher than the melting point, the base metal. So in all four cases, the melting of base metal takes place. So you can say these all are fusion welding processes. So first the heating, then melting, then fusion, then solidification. That is how the welding or joining of the material takes place. Whereas in this solid state welding category, the highest temperature is well below the melting point. So the joining takes place without melting the material, melting the base metal. So in that you can see there are basically two broad umbrellas in the welding processes. First is fusion. These all four categories are under the umbrella of fusion welding. Second is solid state. So that is how you can understand the broader classification of welding. Further, we'll study about all these processes in subsequent lectures. Now, after definition and classification, we'll move towards the applications of welding. The first application of welding is very conventional or traditional, like joining of two similar dissimilar parts. As I said in the definition of welding, the welding is the process of joining two parts. So that joining term is also there. So it is very conventional or traditional application of welding, that is joining. So this joining, why there is a need to join the parts? Why we cannot assemble a parts in a single go, like the whole component in a single go? So that's the reason. Like I'll give you an example of IC engine. You can consider any IC engine which has various parts like cylinder, piston, crankshaft, crank rod, etc. So these all parts have require different type of characteristic or properties. Based on that, they are designed and fabricated separately. So to assemble or join, to assemble a engine, we need to join all these parts together, obviously with the help of welding processes. So joining application find in very variety of industries like automobile, piping, shipbuilding, aviation, everywhere. So moving towards second application of welding, that is maintenance, repair, and refurbishing of components. As you all are aware, wherever you are using some part or component during operation, it needs some repair. It needs some repair or maintenance. So for repair and maintenance, you can use welding itself. Like here in this image, I have shown you some defect in the these pipes, which is like repaired with the help of this welding process. So apart from maintenance and repair, there is some refurbishing of components also. Like refurbishing, in general terms, you can say refurbishing is equivalent to renovating something. So here you can see a very large size drill. Very large size drill is refurbished using some welding welding process. So that is how welding processes are not limited to joining only. During operation or post operation, they some maintenance, repair, and refurbishing tasks are also required. So for those tasks, welding is also used. After from traditional application of welding, there are some like very innovative applications of welding. One of them is in additive manufacturing by welding. Additive manufacturing, you can say additive manufacturing is the manufacturing or creating some part by depositing the material in the layer by layer fashion. So I'll give you one example with the help of this image. Here you can see a cup type of shape, a very conical cup. So you can see this cup is produced or fabricated using the layer deposition. One layer is deposited here, then here, then here in vertical movement. So this is how the layers are deposited so that a cup type shape is formed. To get this cup type of shape, they have used this welding. This is MIG welding, metal inert gas welding, or GMEW, gas metal arc welding. With the help of GMEW, they have produced this cup. So you can see this MIG welding or GMEW is not only used for joining or repairing or refurbishing. This is also used to create or fabricate a part itself. There is another example of additive manufacturing by welding. This is a fan type shape. These fins are produced with the help of additive manufacturing by using some welding process. And you can see the number of layers here. By depositing this layer as per the design of this fan is fabricated or produced, or you can say manufactured. So not all the processes, welding processes are used for additive manufacturing, but there are some processes which can be used for additive manufacturing, like GTAW, GMAW, laser beam welding, electron beam welding. And based on this, like GTAW, if we use GTAW, GMAW, this additive manufacturing process is called as wire arc additive manufacturing, or WARM in short. If we use laser beam welding for additive manufacturing, it is called laser metal deposition, or LMD. If we use electron beam welding for additive manufacturing, it is called electron beam melting, or EBM. So these welding processes are not only used to join the part uh, or for maintenance or repair work, they are also used to create a part. So this is a very interesting application or newer or innovative application of welding. Moving towards another interesting or innovative application of welding, that is fabrication of functionally graded material. Some welding processes are also used to create some material. So here is a very interesting example of material, that is functionally graded materials. For better understanding of functionally graded material, or FGM, I'll post a picture here. This is an example of functionally graded material. If you can focus at the bottommost layer, the composition of material is 20% Al2O3 plus 80% Ni. If you move towards top, you can see a gradient of composition is taking place. Let's see. This is 20% Al2O3. At some top level, it is 60% Al2O3. At somewhat higher, at somewhat top, it is 80%, then 90%, then 95%, then 100%. Similarly, the nickel percentage is also varying, like 80%, 40%, 20%, 10%, 5%, and 0%. So it is 100% Al2O3. You can see a white layer here because Al2O3 is pure white in color. So you can see a compositional gradient from top to bottom or bottom to top. This kind of innovative materials are required in certain critical operations. So these type of material can be fabricated or produced using some welding process. This material, from where I took this example, this material is produced using this laser beam welding. You can see written here laser. So laser beam welding is used to produce this functionally graded material with the help of powder feeder. The powder of Al2O3 and nickel is deposited here, and with the help of laser beam it is melted and fused here, and that's how in layer by layer fashion, by varying the composition with the help of this powder feeder, we can produce this FGM. So I have shown you some like conventional and innovative applications of welding. This is all about today's lecture. I'll get back to you soon with some more interesting topics on advanced welding. Thank you so much.